So let's come to the main point. In the second case, if I ask you what would be the angle, so would it be 60? So your answer would be no. Why? Because I told you that it's not about here the tail and tail are not matching, head and tail are matching. So actually the angle between two vectors would always be said the angle between their tails, subtended by their tails, not by tail or head or head or head. So this would be the angle. So if this was 60, so what would be this? Okay, this is not looking 60, but take for example 180 minus 60, 120. So 120 would be the angle. Okay, there is one more point. If you had thought that, say I draw this vector and I draw this vector, and the angle between them is like 30 degree, but you must ask the same problem to me. You must have thought, it comes to your mind like this is 30, but why didn't you take this angle? You know which angle we need to take. Is this 30 or 330? Is this 30 or 330? How do I get to 330? Simply 360 minus 30. The remaining angle would be 330. Okay. So which one is correct? Actually, we need to take only this one. Okay. Think it again. In fact, see it again. If the angle between two vector here is 120, so which angle I need to take? Whether this or this. This angle is also subtended by their tails, na? So this would be 360 minus 120, that is 240. Or I'll draw to you for your sake this and this. Say for example this is 240. So this is 240. So this would be of course 120. So which angle would I take? 120 here or 240 here? So the answer for that is you need to take always the smallest angle. So 120 here is the answer, 120 here is the answer. Actually the angle between two vectors can always be from 0 to 180. The angle between two vectors can be 180 and 0, and the numbers between them, it cannot be greater than 180 or cannot be less than 0. So this is the fact. Okay, we need to take always the smallest angle. So there are some properties with respect to the vectors. First one I told you, the angle between two vectors has to be greater than 0 or less than 180. Second one is, if there is one vector, you can shift vectors. If this is the vector, you can shift it parallel here, you can shift it here, you can shift it here. It doesn't change anything. So vector, these all are a vector, same length, same direction, eastwards. So you can shift them parallelly, no change. It brings no change to the vector. Shift them parallelly. Okay. Second important point is, if this is the vector, say for example with the x-axis, this vector is making 30 degree. With the x-axis, this vector is a vector having magnitude 5. So this makes an angle of 30 degree with the x-axis. Okay, I'll draw x-axis for your sake of convenience. So second property is that if you move or rotate a vector by 2 pi angle, with an angle of 2 pi, if you rotate a vector by an angle of 2 pi, it doesn't change the vector. It doesn't change it. You can feel it yourself. Would it change anything? Because it is at 30 degree and you again rotate it by 360. It is there, and you rotate it again by 360. It again comes there, na? So it's not going to change anything. Actually, here you are, by rotating, you are just changing the angle. So you are not changing the angle. It again comes to the same point. So vector doesn't change. So this was the third property with respect to the vectors. Okay. So angles we have learned about the angles between the two vectors. How do you need to look for that, and some properties. Now let's come to the main point, addition of vector, which is the important thing. So let's talk of that part, addition of vector. Okay, before addition of vector, I'll just give you a small talk over the types of vector. Okay, so types of vector. First type is like equal vector. If I say equal vector, so if I say two vectors are equal, say A vector is equal to B vector, so they have to be same direction and same magnitude. So A is this, B is this, both magnitude is 5 meter per second, both magnitude is 5 meter per second, and both are pointing towards east. So then I can call them as equal vectors. Then with the name you can tell yourself, if I say parallel vector, so would they need to have the same magnitude or same direction? Magnitude can be changed, but direction has to be same direction. Say for example, there is a vector A and there is a vector B. So it has magnitude of 5 meter per second, it has magnitude of 15 meter per second. So they are parallel or equal? They are parallel vector because they have same direction. Then there is anti-parallel vector. What is the angle between the parallel vector? 0. So angle between these two is 0. Okay, why I raised that topic here, you will understand. Anti-parallel vectors means they don't need to have the same magnitude but opposite direction. If A is this, then B has to be this. If A is eastward, B has to be westward. A's magnitude is 5 meter per second, B magnitude is 7 meter per second. Okay, so then when we are going to say that they are anti-parallel vectors. And what is the angle between them? 180 degree. It's not 0, 180. Okay, then they are collinear vectors. Okay, collinear vectors means simply if two vectors lies in the same line. Say for example, I said this is A vector and this is a B vector. So even they should have the same direction and they should have the same line of action. Say along with the same direction, they should have same line of action. So it is different from parallel vectors. Parallel vector doesn't need to have the same line of action. They don't need to have same line of action, but collinear vector need to have same line of action. Magnitude doesn't matter. So these are collinear vectors. Okay, then coplanar vectors. Two vectors if they are in the same plane. Now two vector would always be coplanar. Two vectors in same plane. I know two vectors would always be in the same plane. So coplanar vector, if you need to check, so you need to check with the three vectors. So three vectors can be coplanar, cannot be coplanar. Okay, it can be the case two vectors lie in this plane, and the third vector line in this plane. So these three vectors are non-coplanar. But if there are only two, so whatsoever there are two, you take any pair A, B, C. A, C are also coplanar. A, B, C together, these all three are not coplanar. But A, C coplanar, A, B coplanar, B, C coplanar. B, C plane is this plane, so they are in the same plane. AC's plane is this plane, they are in the same plane. AB plane, AB are in this plane, so they are in the same plane. So coplanar vectors. Okay, so almost I to tell you, I had told you every sort of the vectors: equal vectors, planar vector, coplanar vector, collinear vectors, parallel, anti-parallel. Okay, so maximum thing I've told you, but there are also some zero vectors, null vector, which is an important one. So this one is sometime it comes at zero vector or null vector. Okay, so there is another one. To tell this, there is one important, very important vector, unit vector. I have told you many types of the vector, but the most important of them is unit vector. I told you those just to get into this point where unit vector, and unit vector, with the unit vector there comes the null vector as well. The unit vector is nothing but this vector has just unit. That means it is not having any magnitude. It has a magnitude of 1. Unit vector has a magnitude of 1. It just only depicts direction. You will understand, don't worry. This is a very simple thing, everybody understand it, but we'll talk of it much. Okay, so say for example, I'll talk of x-axis, this direction, east x-axis. So for that unit vector is I cap, we represent it with the cap. For y-axis we represent with the j cap. For z-axis we represent with the k cap. So the thing is, these all represent only direction, na? They don't represent any vector, the magnitude. They are the vector, unit vector. They don't represent any magnitude. Even in fact, the magnitude is 1, because when nothing is, before, we'll take as 1. So what is zero vector? Having magnitude equivalent to 0. Then the second question in your mind would come, what would be direction? You would say 0, but if it had no direction, then it wouldn't be a vector in the first place. So it has a magnitude, yes, 0, but what is its direction? Indeterminate direction, undefined direction. Okay, you get the zero vector. When you subtract two vector, you get another vector. In the cross product you get a vector, but if cross product of two vectors get 0, then you are getting a null vector actually. Okay, so this is the case of the zero vector. Okay, then we'll start the addition of vectors. Okay, we'll start addition of vector after this.